Welcome to JD's Prep. In this problem, we're told that a car was purchased for $25,000. Research shows that the car has an average yearly depreciation rate of 18.5%, meaning that it loses 18.5% of its value every year on average. The first thing we want to do is create a function that will determine the value, v of t, of the car t years after purchase. The idea here is that every year we are going to multiply the initial value of the car, the $25,000, by a factor that represents the depreciation rate of 18.5%. To find that factor, we can take our 1, or 100%, minus the 0.185 for the 18.5% depreciation. In other words, that tells us that after each year, the car will only be worth 0.815 or 81.5% of its value in the previous year. So our function then, v of t, is going to start off with the $25,000, its initial value at purchase, and then it's going to multiply by 0.815 for every year after purchase. Since you're multiplying by the 0.815 over and over and over again, that means for our function we want an exponent of t. Anytime you have any model that is involving repeated multiplication by the same number, then your variable is going to be up in the exponent, giving you an exponential function. For the second part, we want to determine to the nearest cent, using this function, how much the car will depreciate from year 3 to year 4. So in other words, in that third year, how much of the car's value is going to be lost. If we want to do that, we need to find the difference in price. So how much is it worth after 3 years minus how much is it worth after 4 years. For this, we would need to plug into a calculator in order to find those two function values, v of 3 and v of 4, rounded to the nearest cent. The important thing is that with the nearest cent, that means we are going to have two decimal places, or two places after the decimal point. If we plug these into a calculator here, 25,000 times 0.815 to the third, that's going to give us a value of v of 3, which is 13,533.58. If we do the same thing for v of 4, have 25,000 times 0.815 to the fourth, that's going to be 11,029.87. So at the beginning of year 3, we have $13,533.58 being the value of the car, and for year 4, we have $11,000 or $11,029.87 as the value. The difference between those two, which is $2,503.71, is the amount of value that the car loses from year 3 to year 4. So our answer for this second part would be the $2,503.71.